Today we're going to be looking at solving multi-step equations. So our goal is still to isolate the variable. We're applying PEMDAS in the reverse order. So we're going to add or subtract, then multiply or divide. So let's look at number 1. We have r plus 13 divided by 12 plus 2 equals 3. So we have to get r by itself. So r is in this fraction, so we have to remove everything and then work from the fraction. So we have to subtract 2 from both sides. It brings down our r plus 13 over 12 is equal to 3 minus 2, that is 1. We have to get rid of this denominator. So we're going to do the opposite and multiply 12 on both sides. Cancels out, we're left with what's on top. So we have r plus 13 equaling 1 times 12 is 12. Now we have r plus 13, opposite of addition and subtraction, so we're going to subtract 13 from both sides. Cancels out, left with r equaling 12 minus 13 is negative 1. So we get r to equal negative 1. If we substitute in negative 1 up into our equation and simplify this side, we would get 3. And that's a good way to check to make sure you did it right, because the answer would be 3 in that case. Let's look at number 2. We have 15 minus a divided by 3 plus 7 equals negative 2. We need to get a by itself, and a is part of the fraction, so we're going to subtract our 7. We're doing the opposite. So we're left with 15 minus a divided by 3 is equal to negative 2 minus 7 is negative 9. Now we need to get rid of this divide 3. So we're going to multiply both sides by 3. Cancels out. We're left with our numerator. 15 minus a is equal to negative 9 times 3 is negative 27. Now we have to get a by itself. So it's being added or subtracted here. In this case, it's being subtracted from 15. So 15 is positive, we have to do the opposite. So we're going to subtract 15 from both sides. We're left with negative a. Don't forget to bring the sign down. Is equal to negative 27 minus 15 is negative 42. This negative a is the same thing as saying negative 1a. So we can divide both sides by negative 1. Cancels out, and it leaves us a is equal to negative divided by negative is a positive 42. Positive 42 is equal to a. Okay, let's look at number 3. We need to find 3 consecutive odd integers whose sum is 117. So, we need 3 numbers. Consecutive means they go in order, but they have to be odd. So, if we think of x is our first number, let's start from there. So, if we have numbers 1, 2, 3, 4, 5, 6, 7, and it's continuing on. So if we start with 1, the next odd number is 3. So to get there, we start with 1, we have to add 3 to get to the next. I'm sorry, you have to add 2 to get to the next, which is 3. So if we start with x, our first number, we have to add 2 to get to our next odd number. So this would be our second number. And then the third digit, if we start with our x, we would have to add 1, 2, 3. We'd have to add 4 to get to our third number we want. So the problem says we need to find 3 consecutive odd integers. So these are going to be our odd integers whose sum is 117. So we have to add all of these together. So we have x plus 2 plus x plus 4. And that is going to equal 117. We need to combine our like terms. So we have x, x, and x. So we have 3x. Then we have 2 digits here. We have a 2 and a 4. If we add them, we get 6. That equals 117. Now we have a problem we can solve. So we're going to subtract 6 from both sides. Cancels out. Left with 3x equaling 111. Then we divide 3 on both sides. And x equals 111 divided by 3 is 37. So we found what x is. We did not answer our question yet. We have to find those 3. So we need to go back up to our numbers over here. So our first number is just x itself. So our integers, we know is 37 is our first one. And then 2 more than 37. So 37 plus 2 gives us 39. And then 37 plus 4 is 41. So our answer is 37, 39, and 41. So if you add these 3 together, you would get 117. That one's a little tricky one. Okay, let's look at solving when we have variables on both sides of the equation, or of the equal sign. So we have 8 plus 5c equals 7c minus 2. We need to combine all of our like terms. So I start with my variable. We have a c on this side and a c on this side. I want to move all the c's to the correct side. Since 7 is larger, I'm going to move this 5c to the right. We're going to subtract 5c. Cancels out. It leaves us with 8 equaling 7 minus 5 is 2, but it's a c minus 2. Now we need to move our number or constant to the other side. We're going to add 2 to both sides. It cancels out. We bring down 2c equals 8 plus 2 is 10. Now we have 2 times c. To undo that, we divide by 2. Cancels out. C equals 10 divided by 2 is 5. Let's look at the next problem. We have negative 9 plus 8k equals 7 plus 4k. Let's move all the x's or all the k's to one side. We have 8k and 4k. 8k is larger, so let's move the 4k over. So this is plus 4k, so we're going to subtract 4k from both sides. Cancels out. We run negative 9. And then 8 minus 4 is positive 4. And then we bring down the 7. Now we need to get k by itself. We have a constant over here we need to move it over. So we are going to add 9 to both sides. So we bring down 4k equals 7 plus 9 gives us 16. 4k is multiplication, so we're going to divide both sides by 4. We get k to equal 16 divided by 4 is 4. Okay, let's look at the third one here. We have 6 times the quantity of negative 3x plus 1 equals 5 times the quantity of negative 2x minus 2. We have parentheses here, so we have to distribute before we simplify. So we do 6 times negative 3x, and that gives us negative 18x. 6 times 1 is positive 6. Now let's simplify this side. We're going to distribute the 5 in. 5 times negative 2x is negative 10x. 5 times negative 2 is negative 10. Now since we got rid of the parentheses, we can combine our like terms. So we have negative 18x and negative 10x. Doesn't matter which side you go, let's move the negative 10x over. So we're going to add 10x to both sides. Negative 18x plus 10x is negative 8x plus 6 equals negative 10. Now we need to move the 6 over. So we're going to subtract 6 from both sides. Get negative 8x equaling negative 16. Negative 8 is being multiplied to x, so we have to divide by negative 8. Don't forget the sign. Cancel. So we get x to equal negative divided by negative is a positive, and 16 divided by 8 is 2. Okay. Let's look at the next 3 problems. So I want you to try these 3 problems by yourself and then come back and check your work. So let's look at number 4. We have to distribute and get rid of those parentheses. So we're going to multiply 2 into everything in that parenthesis. So 2 times 3y is 6y. 2 times 7 is 14. We have to distribute the negative 4 in. So negative 4 times 3 is negative 12. Negative 4 times negative 2y gives us a positive 8y. Combine our like terms. So let's move the negative 6 to the other side. We get 14 is equal to negative 12 plus 2y. Now let's move the negative 12 over. So we're going to add 12 to both sides. 14 plus 12 is 26. That is going to equal 2y. We're going to divide both sides by 2. And y equals 13. Okay. The next one, we have some fractions. We do not like fractions, working with fractions. So let's make this the whole numbers. So to do that, you're going to multiply everything here by the denominator of your fraction. So by 3. By doing that, we get rid of the fractions. So 2/3 x times 3 gives us 2x minus 6 times 3 is 18. 6 times 3 is 18. And then negative 2/3 x times 3 is negative 2x. Now we are not working with any fractions, so it makes it a lot easier. So let's combine. Let's add 2x to both sides. Cancel, so we get 4x minus 18 is equal to 18. Let's move our constant over and add 18 to both sides. So we get 4x is equal to 36. And divide both sides by 4. And x equals 9. Okay. For number 6, we're going to do the same thing. We have these fractions. So let's work with whole numbers. So like we did before, we're going to multiply the whole equation by the denominator of the fraction. Here in this case, we have a 2 and an 8 as our denominator. So we're going to multiply by the larger number. So multiply by 8. So 1/2 times 8 is 4. Minus 5/8 x times 8 is minus 5x equals 7/8 x times 8 is 7x plus 7/2 of 8. That will give us 28. Now let's combine our like terms. So let's add 5x to both sides. Left with 4 equals 7x plus 5 to x is 12x plus 28. Subtract our constant. 4 minus 28 is negative 24. So we have 12x, we have to do the opposite, so we're going to divide both sides by 12. It gives us x to equal negative 2. Okay, let's look at the last two problems. So we have 2/3 of a number reduced by 11 is equal to 4 more than that number. So we need to write this. So 2/3 of a number, so 2/3, we're going to call the number x, is reduced, so reduce is subtraction, by 11. And that is equal to 4 more than a number, so x plus 4. Now that we have our equation, we can solve it. So we have a fraction, let's get rid of that. We're going to multiply the whole equation by 3. So we get 2x minus 33 is equal to 3x plus 12. Now let's combine our like terms. Let's move our 2x over by subtracting it. Cancels out. We have negative 33 equals x plus 12. Let's move our constant over by subtracting. And we get x to equal negative 45. The last problem we're going to look at. We have 5 times the sum of a number and 3 is the same as 3 times the difference of twice the number and 1. So let's set this up. So 5 times the sum of a number and 3 will be 5 times the quantity of x plus 3. They say is the same, so it's going to be equal to as 3 times the difference, so we're going to subtract, of twice the number and 1. And we are going to subtract, not add. Let's change that. There we go. So now let's simplify. To simplify and solve this, we have to distribute. So we're going to distribute the 5 in. So we're going to get 5x plus 15 is equal to 6x minus 3. Let's combine our like terms. So I'm going to subtract 5x from both sides. Get 15 equaling x minus 3. We're going to add our constant over. Cancels. We get x to equal 18. So that is it for solving multi-step equations. Please reach out if you have any questions.